Okay, for the rainfall estimation, as I mentioned before, rainfall data and statistics are the driving force behind all stormwater studies and design. Okay, so adequate and significant of the rainfall design is necessary as a prerequisite for preparing satisfactory urban drainage and stormwater management projects. So this statement basically I obtained from the MASMA too. So that's why they are mentioned about the urban stormwater management. But basically, all the hydrology studies we need to have a rainfall data as become their inputs. So the estimations of the rainfalls involve frequency, durations, and intensity analysis of the rainfall data. So the arts of the rainfall estimations for the Malaysia, you guys can refer to the hydrological procedure number 1, we call as a HP01. So the HP01 have been published at the 1982, and the recent update have been published in 2015. So these guidelines or the procedure you guys can obtain from the MASMA too. So basically, those who are graduate like me, I graduate during my time. We are using the MASMA 1. So for the MASMA 1, they're using the old version of the hydrological procedure 01. So the data basically for the rainfall estimation is not being recommended to be used because there is some issue about the data, because for the HP01 1982, their distribution actually is not suitable to be applied. But for the HP01 update at 2050, this one, their distributions of the data is fit well, so we can use. So it's very appropriate to using the HP01 2050 for our study. So as you can see on the right side, so this is the main page of the HP01. So it's prepared by the JPS or the Department of Irrigation and Drainage Malaysia, and being prepared by the Nahrim. So as I mentioned before, the HP01 also being integrated in the Urban Stormwater Management Manual, or we call as a MASMA. So the recent version of the MASMA, we call as a MASMA second edition, have been utilized nowadays. So for me, normally if I want to study the hydrological and the hydraulics, and or if I want to design the hydraulic structures, okay, for example, if I want to design the reservoir or the detention pond, or if I want to design the outflow control, for example, to design spillway, the inlet, outlet. So normally I like to refer the MASMA. So for the MASMA one, which is published, this one MASMA 1, which is published at 2000. So it's very comprehensive concept and theory being addressed in this MASMA. For me, I prefer to using MASMA 1 as my, all the theory that you want to be used in the hydrology and hydraulic studies have been addressed in the MASMA 1. And then at 2012, okay, you can see the DID produced the new MASMA, we call as a MASMA second editions. So MASMA second edition actually is the summary of the MASMA 1. Okay, MASMA 1, they contain a lot of things. Okay, the concept, the equation, the step, everything have been explained very well in the MASMA 1. But for the MASMA 2, okay, they have divide into the several chapters, which much easy and easy to understand, especially to those engineers who like to use the manual for their studies or for their project. Okay, for example, if you in the MASMA 2, they have list the formula to find the time of concentration, TC, okay, which is time taken that water travel from the upstream to downstream. So in the MASMA 2, they just give you, I think, around 3 formula to estimate the time concentration. But in the MASMA 1, they list a lot of the TC. Okay, TC for the forest, TC for the drainage, and much many more of the method to deploy the TC. So you can see the differences between the MASMA 1 and MASMA 2. Those who are beginner, who want to design the hydrology and hydraulic studies, and also the urban stormwater management, okay, you guys can using the MASMA 2. But bear in your mind, if you want to know more on the detail, you guys can refer the MASMA 1. But as I mentioned before, MASMA 1, in terms of the rainfall estimation, which is to identify and estimate the rainfall intensity, okay, you cannot using the data, okay, because the data have some error. Okay, and then the new version, which is the update one, okay, you need to refer the latest hydrological procedure 2050 HP01. Okay, and then at 2014, okay, the MASMA 2 have been converted to the Malaysian standards, so which is MS 2526, which being published at 2014 and 2015. So basically, the Malaysian standard MS 2526 and MASMA 2 basically is the same thing. Just the name of the title, okay, that being changing, okay, daripada MASMA 2 to the Malaysian standard. Okay, the content, the chapter, the volume, everything is quite similar for these two guidelines. So to design the rainfall, or others word probably we can call as the estimate rainfall. We have two ways to estimate. The first step, the first way is we using the empirical equation or the IDF curve from the HP01 2015. So this one. Okay, so this is the empirical equations. I is the intensity of the rainfall. So this one is the intensity of the rainfall. So the unit is millimeter per hour. And then you have a gamma, and then you have a kappa. Okay, and then you have this one, the N, I'm not sure how to pronounce. And then this one, gamma or omega, I'm not sure. So this coefficient we call as the fitting constant. Okay, you guys can refer to this table. Okay, table 2.B1. So if you refer to the hierarchical procedure number 1, so there is two type of this table. So the first table for the low ARI, and the thing that you see in my slide is for the high ARI, which is between 2 until 10 years. So that's how we determine the fitting constant. So the value of the fitting constant is different for each place. So for example, in this table, you can see we have the first column is the state, And then the second column is the number of stations. And then the third column is a station ID. And then the fourth station is the station names. So they list all stations that being available in the Perak. You have JPS, Teluk Intan, until to the dispensary Keroh. Keroh. Sorry if I pronounce wrong. And then the last of the column, so you can see the 15 constants. So you just take the constant that represent the station that you want to estimate their rainfall. And then you have T. Okay, T here is the return periods. So the unit is years. And then D. D here is the storm duration. So the unit in hours. So if you have the select, if you substitute with the correct and select the correct fitting constant, you guys will get exactly the rainfall intensity for the station that you want to find. So that's the first step. And then if you don't want to use the empirical equations, you guys can refer to the IDF curve. So you can see this horizontal axis is a storm duration in minutes. And then here the rainfall intensity, millimeter per hours. And then you have the several lines for the return periods. So this one for the latest HP01 2015. So for the old guy, okay, normally like me, okay, yang saya zaman-zaman saya belajar dulu during my degree, okay, mesti you guys using this formula, which is a polynomial approximations of the IDF curve, or we call it as a polynomial expressions. So this equation actually from the MASMA 1 or the HP01, the old versions. So this one we don't use. Okay, jangan guna this formula to estimate the rainfall intensity. The second methods, before I forget, the latest HP01, they can consider the factor of the climate change. So they provide you the table, something table 10.01 as being displayed on the slide. And then you can see it's the same like the previous one. Okay, like the previous one, you have state, numbers, station ID. Okay, and then you have the ARI 2 until 200 years. Then here they put the climate change factors. That means if you get the intensity from the calculation from the what we call that, from the empirical equation or the IDF curve, okay, you just times with the climate change factors. Okay, for example, if the intensity you obtain 100 millimeter per hours, okay, and then you just times with the, for example, if you're using 100 years ARI, you take 100 years ARI and then times 1.4. So you will get the new rainfall intensity with the climate change. You consider the climate change factor. So that's the first way. The second way is you derive by your own. That's meant you do the frequency analysis. If you go through the hydrological procedure 01, actually they mention on the step on how we develop by our own. So they put some methodology and then what the step that you need, and you guys can follow the steps. So if you do the frequency analysis, this one is, for me, is much better, because you able to test which distribution that's suitable with your data sets. Okay, I think last time during others lecture, okay, you guys already introduced by the distributions, okay, about the probability, about the functions. So this is one of the example on how we utilize the frequency analysis to get the best distributions. So this is some example on my research. So in this example, I have checked one of the rainfall data over the Alostar. So for this exercise, we select several distributions. Okay, as you can see, we have beta, we have the exponentials, we have gamma, we have GEV, okay, generalized extreme values, we have Gen Pareto, okay, generalized Pareto, and then we have log Persian tree, and then we have Wakabi. So from our analysis, okay, so we try to fit with our data, and then here on this second column and the third column, you can see our distribution have been ranked based on their fitness. So for example, if we look on the Kolmogorov-Smirnov, so you can see the first rank is a log Persian tree, and then the second is a Gen Pareto, and then the third is a Wakabi. And then we look at the Anderson-Darling. So you can see it basically show is the same values. Okay, it depends lah. But some cases the Kolmogorov, Smirnov, and the Anderson ranking, they do not show the same identical rank. So we need to select which one is the best based on these two rank. Okay, so for this example, we can see the log Persian tree is the best distributions. So after we obtain this result, you can get their functions. Okay, their functions and also their probability. Okay, this one you need to check back. Takut saya terbalik je this graph. And then after we using some concept, you will get the IDF curve. Okay, so this is how we derive by our own. So this is the IDF curve, the example of the IDF curve at the site near to the Sungai Pinang. So you can see this is the graph that actually last time I have some consultant work at Pulau Pinang, and then after we create the IDF curve by our own, so we compare with the IDF curve from the Masmatu or from the updated HP01 2050. So basically the value for the IDF that we derive and from the HP01 basically is not very different. Okay, kalau you tengok pun tak begitu besar lah dia punya perbezaan. So this is how it look like, and then this is the step on how we derive our own IDF, or we estimate our own rainfall intensity. Okay, the first step is, okay, you collect the monthly or the annual maximum rainfall. Okay, the keyword here is the annual maximum rainfall data of selected durations from the nearby automatic stations. So the data of the rainfall, okay, most of the time you can take from the DID Department of Irrigation and Drainage. Normally, if you do for the consultations, you need to pay. But if you from the government sectors, if you're doing for the research, the ID quite generous. Normally, they will give freely the data. And then another agency that provide the rainfall data is from the Department of the Meteorological Data, Department of the Meteorological. So you also can obtain the data of the rainfall from them. Okay, so normally if you request the data from the DID, for example, normally they will give you either hourly or the daily rainfall. So that's the duration of the data that normally most of the rainfall station will have. Normally for the 5 minutes, 15 minutes, it depends lah. Kalau kawasan tu kawasan commercialized, for example Kuala Lumpur, there is a certain of the rainfall gauge that have that their measurement it take 5 minutes, 15 minutes. Sebab kawasan tu mungkin selalu kawasan commercialized. That's why they need a very fine scale to measure. But most of the data, most of stations, the most fine scale pun hourly lah, hourly ataupun daily. So if you receive that data, okay, you need to convert, or we need to aggregate the data, okay, from daily. For example, if you receive data from daily to monthly or to annually. Okay, after you convert or you aggregate, you need to find their maximum value. So that's the first steps. For me, if I receive the data from the DID, okay, I do the screening, and also I aggregate to the monthly using the Excel or the spreadsheet. So it's much easy than you do manually. After you aggregate, and then you need to test the data for the quality and the consistency. That means you need to check whether the data is a homogenized or not. Homogenized, that means your punya data tu tidak boleh dipersoalkan lah. Maksudnya you punya data tu tidak mempunyai, macam kita kata data you adalah data yang sebenar lah. Sebab there is a case, okay, suddenly you punya data tu fluctuate, okay, disebabkan mungkin ada kesilapan measurement data, for example. So we need to have a homogeneity test, okay, as you know, you can test by using the S-curve, or nowadays for the S-curve, for the hydrology, if you have work with the JPS, normally they like you guys to test by using the S-curve. Kita nak tengok mana year yang macam tiba-tiba ada error ke apa ke. Tapi kalau for the research purpose, okay, you guys can using others homogeneity tests like the R, we have the MATLAB, we have the SPSS. So that's how we test whether this data is suitable use or is homogenized data, which is we able to use the data for the next stage. Okay, kalau the data tu is not homogenized, okay, you can bear in your mind whether you need to recheck the data, Okay, takut ada macam yang saya kata lah, isu-isu data tu, mungkin data tu corrupt ke apa ke. Okay, that's the first thing. Ataupun you jangan pakai that data, you pakai data lain. Maksudnya kalau you tengok station di sungai tu, mungkin you kena consider station di sungai yang station yang berhampiran dengan station you yang corrupt tu. Okay, so that's the second step. You need to test the data. And then for the third step is you feed the data, which is the annual data, with the various frequency distributions. This one that I mentioned before this, you have a lot of the distributions. You have the GEV, you have the log normal, you have Gumbel. Okay, so most of the time, the simple way to test the fitness, you guys can using the Easy Fits. Easy Fit tu memang simple software. Dan saya rasa you can download from the internet, and then they give you a trial. I think it's around 1 month. Okay, you boleh download and then you boleh try lah dengan data you. Okay, maksudnya you ada data annual rainfall, annual maximum rainfall. Okay, and then you masukkan dalam Easy Fits. Okay, nanti Easy Fit automatically fitkan data you ikut distribution mana yang paling bagus. Maksudnya dia akan rank lah mana distribution yang paling bagus. So the first rank, you boleh select lah that distribution for the next analysis. Okay, and then if you don't want to using the Easy Fits, you can using another statistical software such as R, okay, MATLAB, SPSS, and etc. Okay, after you test, okay, and then you obtain the most suitable frequency distribution. Okay, so you can calculate for the various duration and also for selected ARI. So normally for the ARI 2, 5, 10, 20, 50 up to 100 years. It depends lah on your objective of your study. If you want to estimate the return period up to 10,000 years, for example, so you can do like that. Okay, and then after you calculate the amount, okay, you can convert the rainfall to the intensity and you can plot into the log graph, okay, for the selected ARI. So this is the step on how we estimate the rainfall elasticity by your own. Okay, apa kebaikan? What the advantage when you fit by your own? Okay, the first thing is the accuracy. If you refer to the MASMA, okay, normally MASMA, the HP01, it just cover for the selected stations. And for your information, for the HP01 2015, they just cover for the peninsula of Malaysia only. For Sabah and Sarawak, okay, there is no IDF curve that being produced. So that's mean, okay, kalau le project yang berkaitan hydraulic structure, you kena derive by your own lah. For the Peninsula Malaysia, okay, like yang tadi yang saya tunjuk tadi, you tak perlu derive by your own kalau you nak lah. Tapi kalau you nak derive by your own, okay, it's the best. Okay, because for the first, you boleh control lah, you boleh tengok you punya data. Okay, and then you can using the most recent data, okay, to fit with your frequency. Okay, that's mean kalau the data yang produced for the HP0 2015. Okay, it been published in 2015, and I believe they will using the data, okay, from the opening until to probably 2014. If the data from the 2014 until the current, so your IDF curve do not capture that event. If your project, for example, yang terletak dekat kawasan Sungai Kelantan, okay, you can see the most extreme floods, the major flood just occurred in 2014. You imagine, dan saya rasa during that time the HP01 for 2015 do not cover the year during that major floods yang banjir kuning tadi. So that's how we the step to test the fitting data, to develop the IDF curve by our own. Okay, and then I think ramai yang macam pening jugalah macam mana nak buat. Tapi most of the time, okay, for the Malaysian condition, okay, their rainfall actually is fit with the Gumbel distribution. So if we want to using the Gumbel distribution, okay, the first step, okay, still same like before this. You need to take the annual maximum rainfall, and then you test the data, okay, and then this step, which is fit the data, you can withdraw and using this formula, which is the relationship between the annual maximum rainfall, okay, and the return period T by the relationship between annual maximum, and the return period can be represented by this equation, which is X. X is the, this one is a rainfall intensity, and then X here is the average of the annual maximums, okay, and then KT is the factor or the constants, which is KT value. You can using this formula, or you can using this table. So it's the same. If you want to estimate the ARI, for example, 10,000, so you need to using this formula, and you guys will get the frequency factor, the KT, for 10,000 years ARI. And then S is a standard deviation of the annual maximums. Okay, so that's the Gumbel distributions.